So let us start about TEDI. Just why it does not work with this one device. PT, not this one. This one. Yes. Okay. Let us start with some comments about the first slide. I like the picture, the image, because it sums up quite well this talk. By stating that a term is a designation of a concept, it highlights the double dimension of terminology. As a matter of fact, we use some terms which belong to linguistics to speak about domain knowledge. And what is important to note is that for domain knowledge, of course, we need some languages, but specific languages. And I like chemistry because it's a good illustration, a good example of the requirement for dedicated languages. And we can note that, of course, there are domains where natural language is also used to express domain knowledge, for example, in literature, in law. In this case, it is important to note that natural languages are used to express, to translate sounds, whereas formal languages are mainly used to express and to represent ideas. And in the case of chemistry, especially in topological formula, you can't read this formula. You can only comment this formula. Well, next slide. Few words to introduce myself for those who don't know me. I'm sorry for the others. I'm Christophe Roche, a professor in artificial intelligence, ERA Chair Holder at University of Crete in Greece, for the TALOS project, a very fascinating and great project. I'm also emeritus at University Savoie-Mont-Blanc in France. I defended my PhD a long time ago, in 1984, in artificial intelligence, one of the first AI PhD in France, in knowledge representation and expert systems. I started my career in private research center in AI in Paris. I was professor in Switzerland in AI and also worked during more than 10 years at University Nova of Lisbon in parallel. In parallel, I taught in Paris, Paris Dauphine, in Alco, and also set up a lab in knowledge engineering and terminology in Liaocheng University in China, Shandong province. My main topic of interest is about the relationships between languages, either natural or formal, and formal, not or, and formal, and knowledge. I started working on ontology in 1988, long time ago. I'm also strongly involved in terminology, both in ISO. I was a project leader of the latest version of the 1087, the terminology of terminology, and I shared during 9 years the French Terminology Committee in AFNOR. I worked also in a lot of applications, terminology and ontology-oriented application in industry, for example, in nuclear plants, solar energy, chemistry, human resources, and also in project in cultural heritage. I set up and participated in 15 international projects. 10 of them were funded by the European Commission. I'm also set up in 2007 the International Thought Conference, Terminology and Ontology Conference, organized every year at University of Savoie-Mont-Blanc and managed by University of Crete. Well done. Okay, so If you are interested in building specialized dictionaries, multilingual or not, including proper name dictionaries, following some ISO principles in terminology, and also in producing dictionaries in W3C standards for the linked and open data and for semantic web, TEDI can be useful, or is useful for you. In the same way, if you are interested in organizing objects, classifying them, naming them, for example, virtual exhibition, TEDI is also interesting. For a more general way, if you are interested in building metadata for semantic annotation for content management system, TEDI is quite interesting. For example, in this case, you can automatically classify data, either about objects or text, on your ontoterminology using the linguistic dimension and the concept of your ontology as a kind of folders. And after that, it's possible to search for information using both natural language, using not only keywords. What is more interesting in this case is to use ideas rather than keywords, and also to exploit the logical relationships between concepts in order to improve the accuracy of your results, which can be whatever the language, but the information classified onto the idea you are looking for. Well, so there are a lot of IT applications, search engine, content management systems, specialized encyclopedias, knowledge capitalization and management, etc., etc. All these IT applications rely on operationalization of terminology. What this means? It's in the sense of a computational representation of the conceptual system, which is an ontology in the sense of knowledge engineering. What is important to bear in mind is that the explicit representation of concepts strongly impacts terminology in its principles and methodology. This approach leads to the ontological turn of terminology. There was, several years ago, a PhD in French whose title is Le tournant ontologique de la terminologie. My eldest son PhD at the University of Grenoble. I'm proud of my two sons. Both of them are computer scientists and clearer than me. Well, just a few words about writing conventions. As we are going to see, a terminology has a double dimension, a linguistic one and a conceptual one. It's very, very important to clearly distinguish them in order to better link them. And in order to stress, to highlight this difference and to distinguish these dimensions, we can follow these conventions. We'll use both color and writing conventions. For example, for the linguistic dimension, we propose to use the blue color and to write terms between double quotation. Whereas for the conceptual dimension, to write between angle brackets, starting with a capital letter for the concept name and slashes for a lowercase and in green color for the essential characteristics, also called differences. Object will be written in italic and in black. Also, since we use a formal language for defining concepts, we need to follow some syntax. Here is an example. For example, the concept whose identifier is sit for one person is defined this semicolon equal operator from the seat concept plus the differentia for one person. Also, clearly specify the relationships by specifying their domain and range. Relationships between concepts, for example, the sub-concept relationship between object and concept, instance relationship between objects, for example, part of relationships, part of is a relationship between objects, even if you specify the part of relationship at a conceptual level, etc., etc. Just to illustrate what we can, how we can visualize this approach, this example of Greek vases about quarter, and we can note in this example that some concepts written in green was the border is a dash border. In fact, it's a concept for which there are not terms which designate this concept. And also we can attach the different terms in different languages. Okay. Just an example about what TEDI can generate in terms of dictionaries, with a clear distinction between the linguistic dimension, the conceptual representation, and also the object dimension. Well done. Next point. Ontoterminology, a very long word. Ontoterminology is built from two words, two keywords, ontology and terminology. Let us start with the most common word, terminology. Everybody uses every day terminologies. So nowadays, there are more or less agreements about what terminology, concept terms are. And terminology, it's both a science about term formation, term definition in relation to a specific domain knowledge. And it's also the result of the application of this science to a specific domain. It means a set of terms. What a term is a specialized lexical unit. By specialized lexical unit, I mean a lexical unit which designates a specialized knowledge. About term, A2, I think we can agree that a term is a verbal designation of a concept. And what about a concept? Let us say a unit of knowledge. It's a very large, broad definition which can gather different meaning. Anyway, okay. So by stating that a term is a verbal designation of a concept, and that a concept is a unit of knowledge, so it's extra linguistic knowledge, we state that terminology has a double dimension. And to illustrate, let us take the famous example of Wüster's dictionary in mechanics. Wüster is considered as the father of the classical terminology. And where are the terms, the concept, and the definitions? What is interesting, if you ask, for example, a linguist, where terms are and or to comment, see this page of his dictionary, probably he will say that, well, guide bushing, guiding bush are the terms whose equivalents in French are doux de guidage, manchon pilote, etc. And the definition is, oh, by the way, the definition of what? Of the concept or of the term? Is a bushing serving as guide for a cylindrical rotary element, etc., etc. And probably he will say that the drawing is an illustration of the definition. Well, if you ask the same question, let us say a Chinese engineer because we have Chinese colleague here, who can't speak English nor French. It does not matter. He will understand this. The most important for him is a drawing. And the text is only an explanation, some comments about the domain knowledge. Indeed, if I open, for example, a logic book, I go directly to the logical formula. And only if I some problem to understand this logical formula, perhaps I will read some explanation in natural language. So it's very, very interesting. So let's just focus to the textual part and the drawing. Guiding brush are terms, no problem. What about the text? What about the, definiendum and definiens? So a brushing serving as guide, etc., is the definition of the term, not the definition of the concept. Since you agree that a concept is extra-linguistic, you can't define a concept in natural language. By the way, this definition of the term is an explanation in natural language of the concept denoted by the term. And the concept is here. And more exactly, the definition is a representation of the concept. And what is very interesting nowadays is that this representation can be computed in an artificial language. Is what we are going to see. So, just to sum up this part, there are two kinds of definition. A lexicographic definition, also called definition of word, mainly used in textual terminology. It means terminology focusing first on text. And just to quote Alain Ray, a very great terminologist, fortunately past, and to quote him, the meaning of words in this case depends on how they are used into discourses. As for the lexicographical definition, it concerns only the size of a language. It explains meanings while trying to distinguish not concepts and classes of things, but meanings and classes of use of signs. Very clear. And what about terminological definition using conceptual terminology? Also called definition of thing, is a definition of the concept denoted by the term. From Aristotle's, Aristotle, I love Aristotle. From Aristotle's ontological definition to the constructive definition of mathematics. Constructive is a very, very important word that, unlike definition in natural language, which never grabs the definition, the concept, but only speak about words, about concept. It's natural language is mainly a meta language. In this case, you build something which can be manipulated, which can be computed. We remain on the same ground. We do not define words, but terms organized into structured systems and reflecting a conceptual formal is also important, consistent into parentheses. It means that you can prove some logical properties, organization, whether or not it's considered as reflecting the very structures of being. Well, so how these two kinds of definitions are linked? Since terms belong to linguistics and there are definitions of terms. So term, linguistic dimension, denotes or designates, it's not the same thing. Let us say designates because it's a vocabulary used in ISO. Designates a concept whose identifier is sit for 1%, etc. This concept, if you follow a theory of concept based on Aristotle, ISO, or in TEDI, it will be defined as from the sit, the generic concept sit, plus some essential characteristics for one person with fit, etc., etc. From this formal definition, it's possible to generate a template for a definition of the term in natural language. It's quite easy to do it. And of course, you can edit this pattern to improve the wording, for example. Okay. Done for terminology. What about ontology? Well, an ontology, as we're going to see, is a specification of a conceptualization. The core of an ontology is a notion of concept. So what is a concept? It's not so easy to define. So what is it for? One of the main, because not only one goals, but one of the main purpose of a concept is to organize the objects which populate the world. And also to understand what? Nature of objects? Okay. Well, how we can do that? There are mainly two different approaches. The first one is to consider the object, how you can perceive them. And in this case, you describe objects. We don't define objects, we describe. So it's the easiest way of perceiving objects. The second approach, more complicated, is how you conceive, how these objects are thought. And in this case, we can define concept. So description and definition are not at the same level and not for the same topic. Okay? So we can say that a concept is a unit of knowledge about a plurality of things. In order to structure these objects into sets of objects which can overlap, and each of them gathering objects verifying a same property. Okay, so based on this consideration, you can specify different theories of concept, either focusing on nature, essence of things, if you consider that essence of things is useful or exists. Not everybody agrees on that. And the essence of thing, defined as essential characteristic. What an essential characteristic is a characteristic such as if you remove this characteristic from the object, or from the object is no longer what it is. So you are mortal, you are no longer mortal, you are no longer human, but gods. Okay, so concept. The second approach is about description of things. So as I perceive things based on descriptive characteristics. For example, your age, your address, your professions, and so on are descriptive characteristics. These characteristics define the current state of an object. When essential characteristics cannot be valued, it's a case of essential characteristics we can change, also called accidents. And the last but not least notion is notion of relation between objects. This point is very, very important, mainly because most of approach now we rely on relationships, many also to the modern logic and the theory of sets, theory of relationships. And the idea is to define classes not based on the nature of object of the classes, but on the relationships between individuals. For example, the class of Parisian is a set of individuals, set of X, who are person and lives in Paris. So it's quite interesting. And this notion, these notions allow to define classes as a set of objects verifying the same property. Okay. So these categories of thought, essential characteristics, descriptive characteristics, relations, allow to define concepts and classes. Let us take an example. Same example about Greek vases. About these vases, just let us go to the archive, Beasley archive, and where there are some definitions about quarter. The term quarter suggests mixing vessel, etc. Served as symposium was mixed with water. So it's quite easy to find out an essential characteristic of what quarters are in terms of functions. Main function of a quarter is to mix wine with water. About column quarter, A2, looking at the name is very important, and because sometimes names bear some essential characteristics, and also about its definition, named for its column-like handle. So column-like handles is probably an essential characteristic. So if I want to define the concept of quarter, it's quite easy. Concept of column quarter. In this case, a column quarter is defined by two essential characteristics. So I follow what I said previously about writing this category, different categories, concept and essential characteristics. So defined by the set of for mixing wine. Oops. Okay, I could quite it, and with column-like handles. Now, if you want to define a column quarter as a class, how can I do that? Knowing that a class is defined according to the relationships between individuals, you have to change your way of thinking in this case. You have to think a column quarter as a set of individuals which are linked according to some relationships. So how I can do that? It's quite simple. You can take a hammer, break down your quarter into pieces. So your quarter is a set of elements linked together. Okay, it's fine. It works. So a column quarter is a set of individuals which are vases, and for which there are other individuals, column-like handles, which are parts of your column quarter. So it's fine, it works, but you have to change your way of thinking. Okay, so now we can define what an ontology is, and let us start with the famous Gruber's definition, one of the first one. A short answer is a specification of a conceptualization. So the definition of ontology coming from metaphysics, but in this case for knowledge engineering. So from the knowledge engineering point of view, an ontology, is a specification of a conceptualization. That is, an ontology is a description. Definition will be better in this case. Like a formal specification of a program. Formal specification is more definition of the concepts and relationships that can exist for an agent or community of agents. This definition is consistent with the usage of ontology, etc. Let us go to the second one. I like it. Also because Protégé, I would say perhaps some of you know Protégé, a very famous environment for defining, for building ontologies based on classes, not on concepts, on classes. Ontologies are used to capture knowledge about some domain of interest. I fully agree. An ontology describes the concepts in the domain and also the relationships that hold between those concepts. Different ontology languages provide different facilities, and this point also is very important because you can't think without any language. And just to sum up, a definition I gave 20 years ago, but updated, and which sums up quite well all the different definitions. An ontology is a shared definition of concepts and relationships of a domain expressed in a formal and computer-readable language. Just to give one example, in medicine, CT for clinical terms, is quite interesting because this ontology can be exported in RDF. I will say a few words about that. And you have here a representation, since it's a kind of classification. It's not the same thing, kind of organization. There are different classes, a lot of classes in the case of SNOMED CT, as you can read it. For example, about drugs, about products, and so on and so on. Okay, now it remains to combine the two, ontology and terminology, into a single paradigm. An ontoterminology is a terminology whose conceptual system is a formal ontology. Putting first ontology, it's a means to highlight the stable knowledge. An ontology is quite stable. Of course, it does not mean that you can't update an ontology. From time to time, you have to do it. But putting ontology first is a means to highlight on the stable aspect of an ontology. So it's a terminology whose conceptual system is a formal ontology. The term was coined in 2007 in an article in the first TOD conference. Le terme et le concept fondement d'une ontoterminologie. An article which relies on the first article published always in French, terminology et ontologie in the langage journal. Okay, and there is, if you are interested in this topic, there is a website dedicated to terminology. Well, so ontology is a central part of your ontoterminologies, and you can share this common ontology between different languages, which is a means to manage multilingualisms and also to preserve the linguistic diversity. If you want to take into account a new language, it's quite easy. You have not obliged, for example, if you are interested in finding out all the equivalent from a given natural language to other natural languages, you have not to explicitly specify the different things between the different natural languages, but only to attach your new language system onto the ontology, and the system will automatically calculate the equivalence between languages, and if they are not precise or strict equivalent, is able to propose more or less other types of equivalence. And since the system relies on two semiotic systems, linguistic and formal, conceptual, ontoterminology relies on a double semantic triangles, which clearly identify each element. For example, a signified meaning is not a concept. Of course, the link is not a concept. In the same way, a term is not a concept then. Of course, we can. Some link is possible. Well, now, how to implement this notion into TEDI? Okay, let us start with a workflow. At the starting point is the expert. Not only we don't want to replace the expert. The experts are required, needed, is as a starting, but also the central point of this approach. Based on some information about data, knowledge, and so on, the expert will build ontoterminologies, which can be exported as knowledge bases, represented in two different formats. For example, in RDF for the semantic web and the linked and open data as knowledge graphs, in HTML for dictionaries in the case of TEDI or object collections, in XML, for example, TBAs, terminological based exchange, CSV. These different knowledge bases can be used for different applications. For example, you can query directly knowledge graph using a Sparkle endpoint. You can upload this knowledge graph into Protégé, use them for LLMs in order to improve the accuracy of the results, to use for semantic annotation, content management system, and so on. The HTML formats are directly human understandable by the experts. TBAs can be used for translation purposes, and CSV, for example, for CMAP tools. Building this ontoterminology is quite a complex task, and in order to help users, TEDI integrates two terminologies. The first one is term guided. The idea is based on the idea that a concept is a set of essential characteristics, a set which is stable enough to be named in a natural language. Just I repeat because it's very, very important. For example, now I don't build directly my ontology, my conceptualization. I use mainly this term-guided approach based on the fact that a concept is a set of essential characteristics, which is the set stable enough to be named into a natural language. But there is also, on the opposite, an object-oriented approach based on this idea that an object share the essential characteristics of the concept of which it is an instance. Very important. Just to note also that TEDI integrates and embeds several mechanisms, several algorithms for reasoning and checking. Checking on the fly. So it's not possible to build, let us hope, it's not possible to build inconsistent ontologies unlike Protégé, for example, where you have to check afterwards. In this case, the system TEDI proposes only valid options. And there are also some metrics we can generate and analyze these reports about about the different terms, proper names, objects, and so on, how they are connected. Okay. What else about this one? Okay. Let us focus now about TEDI before exercise. So the theoretical foundation of TEDI are based on the previous slides. An ontoterminology is the terminology whose conceptual system is a formal ontology. Okay, great. A term is a verbal designation of a concept. Fantastic. A concept is a unique combination of essential characteristics. Okay, so following Aristotelian principles and ISO principles. And a concept, as I said previously, is a set of essential characteristics stable enough to be named in a given natural language. What else? So, a concept is extra-linguistic. A concept name is not a term. I know that concept name is not a suitable expression. Identifier will be better. So, concept name, more exactly an identifier, is not a term. As a matter of fact, a term is given from discourses. When a concept name is built in such a way that by reading it, we understand the nature of the objects subsumed by the concept. I repeat it because it's very, very important. A term is given from discourses. So you can extract some term candidates from text using natural language processing and so on. When a concept name is built, how? By the way, how? We can follow the Aristotelian principle of naming species from the genus name plus the differential name. For example, the term share denotes a concept name whose name is seat for one person with feet with back. Don't worry, the name can be very long. But if you want to speak about this concept, of course, you are going to use terms. And don't worry about how to write this name. TEDI automatically manages the concept names. And the relationship between formal definition and definition of term are automatically also managed by TEDI. Just last slide about this theoretical foundation. Ontoterminology standardized. The main goal of standard. We don't want to standardize natural language, and it's impossible. We can't standardize natural language. So ontoterminology standardizes the only thing that can be standardized, namely knowledge of the field, and preserves what must be preserved, namely linguistic diversity. It's very, very important. Linguistic diversity, very important, and we have to preserve it. And the best way to do that is to share a common ontology. So if a conceptualization is worded in natural language, because I speak, I give this talk, I speak too much. Okay, it's defined in a formal language guided by epistemological principles. Epistemological principle is a key word when you build ontology. We have to, before taking an environment, don't use directly an environment, don't use directly protégé, don't use directly TEDI. First of all, yes, think about your conceptualization. What are the principles, the epistemological principles I need for my conceptualization? And after that, choose the right environment, the right tool. Okay, so before running TEDI, about the environment and before the break. So the first window when you run TEDI, it opens a launcher. This one, all the functionalities, all the operations are done from the launcher. It's the core of the systems for opening editors, specific editors, for exports, for analyzing and for searching, etc. It's a core of the systems. And from this launcher, you can open dedicated editors for the linguistic dimensions, for term editor, proper names editor, and for the conceptual one, for concepts, attributes, relationships, and objects. So before the coffee break, we are going to play. Now it's time after the coffee break to play. And just let me introduce the example we are going to implement. We are interested in the ontoterminology of seeds. So there are different objects called in different names from different natural languages, in French, in English, in Chinese, for example, it's a, okay, I hope it's right. So what we want to do? We want to, to define terms, knowing that a term is a designation of a concept, and we would like to define the terms for this example: sit, chair, armchair, bench, couch, and stool. and you want to define precisely the concept denoted by these terms. Knowing that a concept, you know that now, that is defined as a unique combination of essential characteristics. So the first issue is to find out the essential characteristics, okay? To find out this. If you agree, of course, on the previous definition of what a concept is. And after that, how to combine them. Knowing that, for example, 10 pairs of two exclusive essential characteristics allow to create 1024 leaf concepts, terminal concepts. So we need an environment to combine. So the principles are not so complicated. What is complicated is how to manage all these different possibilities. So about the first point, first question, how to find out the essential characteristics. Of course, we can start by opening dictionaries. Let us see these differences. I don't remember where I took this definition. Okay, chair is a piece of furniture for one person to sit on with a back, a seat, and four legs. It's typically a definition of thing based on the essential characteristics. Okay, great. So I know that piece of furniture, perhaps it's wood, the top concept, and for one person with a bag, seat, and four legs are essential characteristics. Armchair is a chair with armrest. Great, do you agree? Oh, by the way, yes, of course, I can say that. But what? If you say that an armchair is a chair, is it correct to say that? What about armrest for a chair? It is not mentioned in the previous definition of chair. But if you say that an armchair is a chair with armrest, a chair is without armrest, right? Okay, but if an armchair is a chair, it inherits the essential characteristic of a chair, which is without armchair. But we say that with armrest. Okay. You in natural language you can. Oh yes. Oh, sorry. Different. Yes, but if you say that an armchair is a chair. That you mentioned before. Yes, you are right. It's important to say, of course, you can say that an armchair is a chair with armrest. Of course, you can do that, but it's not correct. From a logical point of view, it's not correct, but you can say that. Because if you say that the armchair is a kind of chair, armchair inherits the properties, in this case, the essential characteristics of a chair, which in this case, even if it's not mentioned, is without armrest. Okay, anyway, in natural language, it's a very powerful means of expression. Natural language, said, you have to be preserved. When you say that, for example, that mercury is a liquid metal, stop. Okay.
Have a look at this term of definition. Going to represent this type of information. Also, people from Zoom, feel free to reach out, write on the chat, or also open your mics and.
Watching the chat perhaps is better. Of course, you can say that. It's important to be able, you can say that. It's correct to say that. But from a logical point of view, it's not correct. Anyway, when you say, for example, that mercury is a liquid metal, of course you can say that. But from the domain knowledge, okay.
This example.
All right. I say nothing.
People, we hear from the people online and on site. If you're doing knowledge representation and you want to represent this type of knowledge, this information.
So I know I have not to talk. Anyway, it's also behind these remarks, there is a problem of open and closed world, which is also quite complicated because it's not because you say nothing about with armrest and without armrest. It doesn't say that. For example, it's a closed world. If you say nothing about something, it means that this thing is not possible. But it's not so simple. I'm not sure that it's quite.
Yes, a piece of furniture for one person to sit on with a back, a seat, and 4 legs, and then armchair, a chair with armrest. Dimitri.
Okay, I think it's my definition. If you define the chair as something that can sit on, you can cover a level of both legs. And then you can define, I think, I'm not my favorite. Because I think you can define an above level things that you can sit on. Have the chair and the armchair. If you find the chair as a thing that doesn't have an armrest, of course, it has to be defined on a level above that. Not sure.
Yes, I understand what you say. In fact, it's the reason why it's necessary to formalize definitions, because there is a lot of things which are not said explicitly, but implicitly. For example, the definition of chair in the TLFI, Trésor de la langue française informatisée, very big dictionary of words, very interesting. In the definition of chair, we don't know if it's for one person or for several persons. Perhaps you can put on the stack several people as a stack on the same chair. Okay, is the reason why we really need formalization. In this case, it's not really a problem because it's a daily life example. But imagine is, for example, a nuclear plant in some aerospace applications. If you are not precise, it can be very, very dangerous. Okay. Anyway. Yeah, yes.
Say whether it has arms or not. But we all know that the chair normally has not arms. And then to take it in the armchair definition, you take as a prerequisite that it is a chair, which we have defined, it's not stated, but it's without. And then you add the characteristic with arms. But these characteristics are mutually exclusive. So I asked Christophe, is this a bad dictionary definition? Because I've been a lexicographer for many years and thankfully get it right.
No, it's not a bad definition because, as Vangelis said it, you can say that. So it's correct. Yes.
System like TEDI, it's the rule-based system.
Yes, but it will TEDI will check the formal definition. And you have the liberty in the linguistic definition to change it. It's not a problem. It's really important. You can have or propose a different definition in natural language. It's not really a problem, since we can share the same conceptualization which is consistent, so we can understand why we disagree, for example. And this point is very, very important. In fact, we need to rely on the sound ground. And the sound ground is a logical part of TEDI. Okay, so the next means it is comparing object, for example. And in this case, yes, so of course you have to take some typical examples, typical prototypes of your classes. And I can see that, of course, in this case, they are armrests, and this one is for one person, this one also, but not this one. So it's quite, and it's not because it's material, it's physical things. You can do the same approach for more abstract object. For example, about sentiment, what the relief is, there are positive and negative and neutral sentiments. Sentiments about objects, sentiment about people, sentiment, etc. So you can follow the same approach even for more abstract knowledge. Okay, right. So now, how can I proceed? You can draw, and it's a very, very useful approach. We can start by drawing, because in this case, it's a means to get out the trap of natural language. I draw a circle for the seat concept, for the chair concept, and so on. It's very, very useful. Nevertheless, drawing is also a kind of trap. If you build a quite big, because it's quite rigid, you have quite a rigid classification of concept, and you want to take into account a new one. And sometimes you can't do it without breaking down your tree. Of course, you can create a new tree besides. It's very, very important. It's the reason why. So also, don't worry, I draw. When I start working, paper, I love paper and pens and blank notes, a lot of, okay, I draw. But as soon as you have identified the essential characteristics, very useful means is to use an array of differences with at one end, left part, let's say the left, depends, okay, left, right, okay, the objects. And on the other end, different names in the different languages. I should put Chinese because Chinese is very interesting for the either Chinese word. Okay. Anyway, and in this case, well, so I have identified axis of analysis and axis of analysis gathers exclusive essential characteristics. And in this case, I know that there are seats for one person or several people, not person, people, with fit, without fit, with bag, etc., etc. And about this object, I don't know if you can see my mouse. Okay, let us say yes. Named chair in English and chairs in French. This term designates, or more exactly, the concept designated by this term gathers, or the concept gathers this essential characteristic is for one person with feet, with bag, and without arm. Great. And based on this essential characteristics, you can automatically create an identifier, seat for one person, etc., etc. And you can do it for all of them. And from these formal definitions, it's also possible to generate definition natural language. So it's a very useful means in this case because you have not to try to put in the right place in your tree your new concept. Do this, and if someone or if some of these concepts are more generic, don't worry, TEDI will tell you that this concept is more generic than this one, so you can change the place. And after that, you can, of course, for explanation, you can draw, in this case, a porphyry tree in order to propose a quite credible or to clarify your organization. And in this case, siège or seat denotes this concept, and you can, oh, by the way, you can also note that in this representation, I've put inside the box whose name is SIT, descriptive characteristics. It is very important. If you are interested in knowledge representation in AI, probably you know that there is other means for building classifications or conceptualization based on the same structure, where the structure of the class corresponds to a set of attributes, a set of descriptive. But don't structure your ontology based on same descriptive characteristic, but the essential characteristic, in fact, define the backbone of your ontology. And after that, you can put descriptive characteristic which, in fact, correspond to the flesh of your body, of your ontology. And you cannot, in this case, that color is a descriptive characteristic whose possible value are, in this case, white and black, and this descriptive characteristic will be, of course, inherited by the sub-concept. It's what is done in TEDI. Well, so it's the first window. By clicking on accept, so you accept the license for using TEDI for non-commercial use only. Okay, done. First things, in this window, you can find some information about the version, when the version has been created, and when it was updated, in this case, in 22 of February. Well, so this one is a launcher. You can find some information about it, especially, of course, you can go directly to the website, but there's some icon, question mark, which gives information about where the question mark is. In this case, this one, it's about ontoterminology, so an OTB, which is a suffix of your file, which contains a list of ontoterminologies. TEDI use object-oriented database. It's a OTB format, so it's a specific format specific to the object-oriented programming I use. So the first things to do is to create a new ontoterminology base. So you create a new, yes, okay. And I want to put it where on my desk, and it's an ontology of SIT. So SIT. The system will automatically add the suffix .otb. So OTB is a database which can contain several ontoterminologies. In this case, my database is empty. So you can click on this icon, help, on ontoterminology. Okay, the terminology, we know that. Okay. Now I have to create a new ontoterminology. I can use the same name, is SIT. Fine. Author, list of contributors, as Maria said. If you click on it, you have, so far I did nothing, so no contribution. You can precise domain, furniture, subdomain, let us say SIT, other domain, etc., etc. Comments first. My first training. Okay. Okay. About language, by default is English. There's two predefined language, English and French. You can create a new language, Greek, Chinese, up to you. TEDI is able to handle specific character, Japanese character, Arabic character, Greek character, and so on. Cancel. Well, so there are different ways of using TEDI. You can use it in a very, very simple way. I mean that, for example, so in green, conceptual dimension, and in blue, the linguistic one. Let us start with a very, very simple example where I'm going to create my ontology. I know that a chair is a kind of seat, so you can easily visualize that the root is a concept seat with 4 sub-concepts: chair, armchair, bench, and stool, for example. So I can do it without specifying formally what a concept is. So if you click on the concept dimension button, it displays the different options: concept editor, object editor, axis editor, relation editor, and attribute editor. Let us start with the concept editor. So it's quite complex. I know that. Just click on some icon. Help. This what? Hierarchical list of concepts. Oh, okay. Only takes into account the generic relationships which are explicitly declared. As a matter of fact, the TEDI is able to infer generic concept, but it will not change the relationship except if you said it explicitly. Okay, let us start with the first new category of seat. So don't worry about angle brackets, uppercase. The system will automatically add the angle brackets and put uppercase for the first letter. So seat, first one. I can use sibling, not sibling, but new subconcept. Let us say share. Up, okay. I'll notice one sibling cancel with sibling, share, armchair. Share, okay. On the sibling stool, on the sibling bench. Okay. Is it okay for everybody? You can do the same thing, of course, with protégé, with subclass of, subclass of, subclass of. Very, very simple. And you can note that TEDI display no own difference. It means that there is no definition. It's the reason why it puts an equal symbol. So it infers that armchair, chair, stool, seat have the same definition from a formal point of view. Okay. Is it okay? Let us say yes. Now, what I can do is to, you really need, I have a very, very big screen. I'm very happy, very, very big screen. You really need a big screen when you want to use TEDI. It's quite difficult in such computer. So let us go to the launcher and now open a new term editor. Click in the linguistic dimension and choose term editor. And you have to precise, and of course you can open at the same time several term editors in English, in French, in Greek, in Chinese, and so on and so on. So very, very big swing. Okay, let us say in English. I guess you have noted that I use from my concept names the same than the term because there is no differences, so the system is not able to create a new identifier. So term is the same way. Click on plus button, okay, and create seat. Okay, done. I put again on the enter, touch, okay, seat, share, okay, armchair. You are not obliged to click always on the same button. Just return, carry return. It's enough. Chair, stool. Oh, carry return, stool. Stool, armchair, and what? Bench. Okay, carry return, bench. Okay. Okay, done. And you cannot, for example, if I click on seat, there is no denoted concept, so no meaning. What else? If you can see my, oh, okay, I'm to wait few minutes. As soon as we're created, this, by the way, for those who know Protégé, the simplest way for representing the linguistic dimension is to use annotation, such as IDFS label or score pref label attached to a class. But in this case, it's not possible to create terms in their own. If you want to do it, it will set up, well, it will raise another problem with how to connect a term which is individual to a class which is not individual. So you have to do that, you have to set up punning, it's quite complicated. Anyway, this topic is for TEDI. You can see that on the right part of the tab editor, you can precise the status of your seat. There are different status possible: preferred, alternative, tolerated, not recommended, obsolete. These status are parameterized. Oops, too complicated. Okay, so since preferred is often used, there is a specific button for that. Click on preferred. You can precise a part of speech of your term to say none. Okay, done. Now, what you can do if you want to link a term to a concept, select, for example, seat, and to select the denoted concept, you have to go to the green part of term editor. Oh, by the way, all the Windows, TEDI Windows are based on the same principle. In the left part, the list of either concept or terms or proper names or object names. And the right part, all the information about the selected item in the list. And in the bottom part is information of the other dimensions. So in this case, in the bottom right part is about denoted concept. There are different means for selecting a concept. We are not going to use FAST. We are going to see what FAST is an implementation of a methodology. But in this case, since there are no essential characteristics, we can go directly to select and select seat. Select. And you can note that if you go to the concept editor, seat was automatically added, of course, as the term associated to seat. So all these windows are connected and updated. Yeah, not to refresh. It's not necessary to refresh your windows. Let us start with armchair. So armchair, select the concept armchair, select bench, select bench, select chair, select chair. Okay, seat is done. Okay, and stool, select still stool. Wait, it's done. Now, since the concepts are structured according to the generic or the sub concept, the terms are also structured according to a hypernymy relationship, not more precisely a terminological hypernym relationships. It means if you click on the hierarchical, we can see that armchair is a terminological hyponym of seat. Okay? In this case, stool, armchair, bench are hyponyms. So the system automatically structures the terms according to the structure of the conceptual system. Now, let us define this terminology in French. So I go back to the launcher, select term editor in French. Okay, great. And now I have to define the same terms, siège, the equivalent of seat. Okay. New one, chaise. Okay. Fauteuil. Okay. Oops. Anyway. New one, stool is a tabouret. Tabouret. A bench is a bank. Okay. And as I said it previously, I don't need to say that, well, siège is the equivalent in French of seat. The only thing I have to do is to say that siège, for example, which is preferred, which is noun, select denotes seat in English. And you can note that if you go to the term editor in English, the system has automatically, no, share seat, okay, oof. The system has automatically updated the equivalent list. Seat in English is equivalent in French is siège. And you can also note that the system has automatically updated the list of terminological hyponyms. Okay? And if we click, for example, about synonymy, because synonymy is very interesting. Discursive synonymy built in discourse and terminological synonym must not be confused. Two terms are terminological synonyms if and only if they denote the same concept. Okay. So don't hesitate to click when there are such a help icon to click on it. So if now I do the same thing, let us say for chaise, for example, select chair. We see that here in English, automatically the system has updated the equivalent term. So it's the simplest way to create your first ontoterminology. And you can, of course, more information. If we double click, don't hesitate to double click on item in the list. In this case, the TEDI opens is a shortcut for opening some windows. And you can, in this case, for example, add external links, such as, for example, RDFC also. And you put a new link. So it's a very, very simple ontoterminology, but not very, very useful. Okay? But it works. If you want, you can export it. Oh, if I want to export it, I have to, I think, to say that all of them. Why not? For example, in the concept editor, if you double click on seat in the associated term list, it automatically opens the term editor. So this one, hierarchical seat is preferred, let us preferred, bench, preferred, Prof, chair, preferred, and preferred. Now, you can decide to export. This is a very, 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 very simple and quite empty ontoterminology. Go to the launcher, select export in HTML and term dictionary. In English, okay, all there are instances, and let us put it in the desktop and first. Sit. Okay, export done. And if I click on it, where is it? Where is it? Here. So armchair, very simple. Sit is hyponyms. I have not defined any definition even in natural language. So hyponym, status, equivalence, concept, no definition, and so on. Okay? But not so interesting. Let us go back and let us create a more interesting ontoterminology, okay, based on the definitions. So let us create a new one, complete. Sit to. Okay. So this one is empty. Sit five concept, 10 terms. Okay. Seat 2, completely empty. So the first things we can do, it's of course we can start in the same way by defining the different terms we want to define. So the same thing, sit, chair, armchair, stool, a bench. Okay. And I want to precise that all of them are preferred noun, preferred noun, preferred noun. Chair is door, no, preferred noun. Gender, can precise also gender. Sit, stool, preferred noun, and sit is door. Okay. Now, if you want to define the concept denoted by sit, if you use fast, it corresponds to the term-guided methodology for defining concept, for building your ontology. If you click on it, the system with list, the differences, difference is an essential characteristic we can use for defining your concept. It's empty. I said no. So the first thing to do, I have to do now is to define my essential characteristic, right? So I can close the term editor. I need to now to define the essential characteristic. So go to the conceptual dimensions and choose axis editor. Conceptual dimension, axis editor. Well, here is. So previously, we have identified several essential characteristics which we can organize into several essential characteristics which can be organized into axes of analysis. The first one is about, let us say that the first one is about the number of people, okay? So, number of people. Accept. So, a seat is, now I have to define essential characteristics under the number of people axis of analysis, click on the new, and introduce for one person. Don't worry about slashes. TEDI will add automatically the slashes. So a seat is either for one person or for several people. Okay, accept. It's done. Now, about fit. I name this new axis of analysis fit, whose essential characteristics are with fit and without fit. Accept. Well, about back. So, a new axis of analysis, let us name it back. Accept. And add the two essential characteristics with back and without back. And the last one, oh, by the way, if I click on this icon, voila, an axis of analysis gathers differences, essential characteristics about the same subject. Those differences are exclusive to each other. For example, to know if a seat has or not a back. Okay. About time. No time, about time, no times is time to speak about time. essential characteristics. The difference correspond to an essential characteristics are exclusive each other. Okay. So the last one is about armrest. So with arms and without arms. Except the new without arms. Now it's done. We have defined all the required essential characteristics. Okay. So now you can either build your ontology directly from the concept editor. You can open the concept editor and define your ontology. I do it anymore since now, about 10 years. Why? Because it's easier to use a term-guided approach. Let us go back to the linguistic dimensions. Term editor in English. Well, so what about sit? Sit is the top. So I need a category for that. But let us forget sit. But let us start with share. So share, I select the term share, which is preferred, and click on the fast button, the fast functionality. So it's the implementation of the term-guided method. And TEDI will help you to select the essential characteristics. A seat is without arms, okay? I select it. And you can note that, of course, TEDI updates the list of essential characteristics. You use it, so of course you can't add with arms. About back is with back, okay. With feet, okay. And for one person. Okay, great. So share is a term which denotes the set of essential characteristics without arms, with back, with feet, and for one person, correct? Right. Now, I asked TEDI to create the concept. Since, as you can see, is a matched concept list, there is no concept. But you need to create it. I click on the create concept. This concept must be in a category. There is no category. So let us create a new category and call this category sit. Great. The category sit has been created. And now TEDI automatically builds an identifier, a concept name, which is sit without arms, with back, with feet for one person. Okay, fine. I like it. Okay. And yeah, automatically created. If you, for example, if you want to open directly the concept editor, you can click in the denoted concept in the same term editor, double click on sit without arms, and you can note that TEDI has created the concept and put it under sit. It's done. Now I can associate sit, select the term sit with the concept sit. Okay. And if I click on hierarchical, so far, share is a term which is an hyponym of sit, but I can say nothing about armchair, bench, and stool since it denotes non-concept. About armchair, let's do the same thing. Click on fast. Armchair. Armchair is with arms, great. With back, okay. With feet, okay. And for one person. There is no concept. So far, there is no concept. So I ask in the same way, I ask TEDI to create in the same category, select, to create the corresponding concept. Great, it works. Same thing for bench, fast. The bench is without arms, okay, without back. Of course, you can define different kinds of benches with why not with arms or without, etc., with feet, and for several persons. Create concept. Category is correct. I create the concept. And the last one about stool, I use fast also. Stool is without arms, without back, with feet, and for one person. Okay, no more. You cannot that. For example, if I delete this one, of course you can delete, remove. Can remove from the selected difference list an essential characteristic. And about match concept, if you click on it, you have the exact definition of the selected concept. So TEDI provides a lot of information in the different items which are listed in a window. So it's for stool, it's for one person. Okay. Create concept, same category. Okay. And if you go back to a term editor, all of them are created in their right place. Since the name can be very long, you can click in the concept editor on the labeled tag, and in this case, the concept editor will use the term, the preferred term denoting your concept. Now, what I can do, close it. For example, it's about term definition. If I click on it, there is no term definition. Generate definitions, there's nothing. Because it's a root, because sit denotes the root of your category. But what about armchair? Ask TEDI to generate, and it generates automatically this definition. Sit with arms, with back, with feet for one person. And of course, you can change it if you want. New generated, I accept it. About bench, okay, generate is good for me. About chair, can generate, it's good. Stool, can generate, it's good. Is it okay? And you can note that chair, there is no equivalent, okay. Just perhaps to introduce, well, in French. Linguistic dimensions, term editor, select the language, and, but not this one, but in French, siège, chaise, just one. Okay. And this one, sit. Share, it's okay. So take this one, select. Okay, share and share. Now, what we can do, for example, is to export. Let us export this new ontoterminology. Term dictionaries in English, all direct instances, and this. Yes. Export on. Let us double click on it. And now about sit, for example, there's no definition, it's normal. About chair, there's a definition, sit without arms, with back, the equivalent in French, and the definition of essential characteristics. Okay. What else? We can also ask the system to generate a report in English. Desktop here, desktop bureau. And reporting. And for example, in this case, I have defined 5 concepts, only one category, 8 differences, no proper name, concept without any difference. Sit is normal because it's the root. without on number of concepts inherited some information. But in this case, the ontoterminology is not so big, so it's not so interesting. Just before to upload a more complex ontology, what we can say? Of course, says about search. We have quite a complex systems. If, for example, all and the system is looking for the substring in every part of your ontoterminology. Well, about list of contributors, only one, it's me. You can expect what I did. And of course, if you double click, it's also a means to edit directly an item. Okay. Let us upload this example, but we see completely defined, this one, sit, ontoterminology of sit, about the conceptual dimension, label, sit, for one person. So in this case, you can note that the system, the ontology, contains a concept without any designation in the selected language. Chair, armchair, and chair, indoor chair. Armchair is defined in English because I'm in English, but you can note that sit for one person is not denoted in any, is not denoted, has no designation in English. This one is more complicated. If I click on it, also hierarchical, you can add context, notes, by the way, about chair, equivalent in French and in Greek. And if you click on more, this one is quite interesting because you can note that there is no equivalent, for example, in Chinese. So if I want to translate chair in Chinese, knowing that I have defined a terminology of sits in Chinese, you can click on more and the system will give some information. For example, for chair, there is a hypernym, a terminological hypernym, which is Hidze, which can be used for your translation. Okay. By the way, about, let us go to the conceptual dimensions. You can note that in this case, this one labeled with a chair, the formal definition of chair, of the concept denoted by the term chair is here, is this set of essential characteristics, sit with feet for one person with back, which are inherited from sit with feet for one person with back. And the own difference, the own specific differences is without arm. We can also note that it's possible to associate attributes such as color, material, weight, which are also inherited. In the same way, you can associate relationships to your system. Let us double click on this one. If you double click on color, the system automatically opens the attribute editor. So color, it's a domain range. I should precise. Or for example, weight, the domain is sit, is monovalue, and is a number. If we double click, for example, for has part is a relation whose domain is sit and range part. This one is also quite interesting. If you know Protégé, for example, it's quite difficult to know which classes use your relation. In this case, for example, causal, if I go back to as part, system automatically displays this kind of button. Only to say that this relationship is used in this definition. Sit, has, part. And this one is very, very useful when you build a complex ontoterminology. Same thing about made of, materials, related to, no, the question, no. Okay. It's the same thing about differences. with fit. And the same thing is important also when you have defined an essential characteristic to know where this essential characteristic is used in which definition of concept. In this case, click in involved concept or select a difference with fit, for example, involved concept, and the system display all concepts which use this essential characteristic. And E2, when you build a very complex ontoterminology, is very, very useful. Try to do the same thing with protégé, which is very, very complicated. Okay, so now, by the way, there's object editor, and in this case, there are two shares instance of the concept denoted by the term share. This one with color, nothing for color, passport, nothing for. So it's a very simple example. Okay, and if we double click on it, you can see that there is a depiction, for example. You can open the URL, this one. Okay, now let us export this ontoterminology of seat. Oh, by the way, this button is very, very useful from the launcher. When you open a lot of Windows, don't hesitate to use this one. It's very, very, very useful. I don't know if you agree, Raphael, but definitely, yes. I see. So let us export the term dictionary in English. Not all on a seat. You can, of course, select, and with all instances. And yes, this one, we use same file, replace, okay, done, double click on the file. So, about bench, okay, sit, okay, great. You can also put some video if you like. Coach, etc. You can also export proper names, for examples. Proper names dictionary. I'm not sure there is proper names in this case. Philosopher will be more interesting. Perhaps you can share after your computer to show us the dictionary cancel. We can also export. I will say now a few words about the export, but just to, in TBX, based on ISO 30042, in CV maps also, but also object collection, for example, in English, on a seat, and okay, object, okay, export done. Where is it? Seat object here. So it's what the system export directly. So this kind can be useful. For example, this one, more informations, and of course. So, few words about interchange format. You can export your ontoterminology in different formats, such as CSV, HTML, RDF, XML, and so on. About HTML, it's a means to directly visualize in human readable form your ontoterminology, either as a dictionary, including proper name dictionary, but also as object collections. About CSV, it's also quite useful, especially if you want to illustrate in a document, using, for example, CMap tools to visualize your concept network and your term network. It's a good illustration, for example, in this case, because coach, armchair, stool, etc., all of them are terminological hyponyms of seat. When you can see that the conceptual system is more structured, is richer. About RDF, about W3C, you can export in RDF. In fact, TEDI, when you look at the RDF file exported by TEDI is quite huge because TEDI uses different vocabularies. RDF, of course, RDFS, OWL for protégé, SCORS, ONTOLEX-LEMON, and OTV, which is a specific vocabulary for ontoterminology. So it's quite big. So you can query directly your RDF graph, and you can also upload your RDF graph into protégé, for example, to check from first, or more exactly from descriptive logic point of view, the consistency. Probably you ask yourself, well, if I well understood what it said, concept class are different. So TEDI is concept-oriented, it's based on concept and essential characteristic. But how you can export in the RDF and upload in protégé? Since protégé is based on description logic, first-order logic, when essential characteristics is a matter of second-order logic. So it's not topic, but perhaps a more advanced course about TEDI. But don't worry, it works, and it works. Just an example of Sparkle query. Sparkle is a language dedicated for querying RDF graph. In this case, what example? Yes, example of seat example. A very simple query, and the result it's displaying the terms and their definition in English. Yes, but what else? It's time to conclude in order to keep some minutes for comments and queries, questions. Okay, cited references, and just to sum up with this slide, protégé is very powerful tool, very important tool, very interesting tool. I taught logic during 30 years, so I like protégé. I really like protégé, and also to compare with ISO. So about the concept theory, ISO relies on essence, on essential characteristics. TEDI, same thing for TEDI. Whereas protégé is based on a descriptive approach, mainly on the relationships. About computational model, ISO, no, it's not the purpose of ISO standards in this case. Protégé, of course. TEDI, yes. About logical formalisms or logical backbone, ISO, no, it's not the purpose of the standard. Protégé, of course, based on descriptive logic. TEDI also implementing more or less a second order logic, so higher logic. And about methodology, there is a methodology in ISO, is a 704, quite interesting standard. About protégé, there are a lot of papers about protégé, but not implemented when in TEDI is implemented. And about checking, it's not relevant for ISO. In protégé, there are several reasoning tools in order to check a posteriori your ontology. It means that you can build a consistent ontology, and after that you have to change. It's not the case for TEDI, which verifies on the fly when you build your ontoterminology. So protégé and TEDI have not the same goals, not the same purpose, not the same foundation. If you are interested mainly in organizing objects, individuals, linked by, for different relationships, protégé is very good. If you want to define concept or to use essential characteristics, protégé is not a suitable tool. It's more, TEDI is dedicated for this kind of approach. That's all, folks. Any questions in the chat?